CIS40A. In this video, I'm going to talk about OSI layers and the OSI model based on the open system interconnection. So we're going to talk about how system is communicating using the OSI layers. This reference model is often referred to when we're looking at networking. And the first layer is going to be the physical layer, in which the bits are being received or sent at your network interface card or your wireless adapter. At this level, there will be electrical, mechanical, procedural, and functional requirement to activate, maintain, and deactivating the physical link between your computer and another system. So in order to establish the physical communication, it has to happen at the physical layer. And in this layer, the device that's operating is going to be your network interface card or your wireless adapter. And in the 7 layers, the second layer is going to be data link. The data link is going to be, it's going to format your data into message increments that's going to be called data frame. It's going to add a header which contains destination and source. So think of it like a mail where you would have where it's going to and where it's coming from. In the layer 2, it contains 2 sublayers called the logical link control layer and the media access control layer. So logical link control LLC is responsible for error correction when the frame is sent. The media access control layer, your MAC, is going to be used for physical addressing, and so your MAC address happens in layer 2 of the OSI. And it's going to determine whether the traffic on the medium is going to have any kind of collision. So collision detection occurs here in layer 2. And in the notes, it explains the description of your media access control. So the physical addresses are ingrained or burned onto the network interface card or your wireless adapter. It is a low-level address, and it's used to determine which system is sending and which system is receiving. This layer actually prepares the data for packet conversion, which is in the layer 3, is when packets is being handled. So data link layer will convert signal that's passed from the physical layer, which is in bits and bytes, and then it's going to convert that to the data frame, which is then passed into the packets of the network layer for later processing or routing. So in your assignment, it asks for a specific layer in the OSI. For question number 7, it asks you which OSI layer sends and receives bits. That will be layer 1, physical layer. Question 8, the device IP addressing is accomplished in which OSI layer? That will be network layer 3. So in the next part, I'm going to talk about the OSI layer 3. In the layer 3, which is known as the network layer, this layer is used to manage device logical addressing, and in this layer, IP address is used. It's going to be able to determine the location of the device in the network based on your subnet mask or your segment, your network values. And it's going to determine the best way to be able to move your data, or known as routing your data. The router is operating in the layer 3 of the network, which is the network layer of the OSI. In layer 4, which is the transport layer, this is going to provide the end-to-end data transport services, which establish the actual logical connection between the host and the destination host and the internetwork. So in order to establish connection, which is TCP, it has to happen in the transport layer. Hence the name, what you see with transport control protocol. So this is where that occurs. Certain certain protocol happens in a certain layer of the OSI model. In layer 5, which is the session layer, this is going to coordinate communication between systems, and it's going to organize the communication in 3 modes: simplex, half duplex, and full duplex. We will come back to this when we talk about certain route and also for session requirement. In layer 6, which is the presentation layer, it presents data to the application layer, and it's responsible for data translation and code formatting. So when the system receives the data, it needs the presentation layer to be able to format and put all your data back into what will be presented in the next layer, which is the application layer. So presentation actually put everything back into order as data is sent in, it gets disassembled when it's sent. In layer 7, which is the application layer, it acts as an interface between the application of the program. So for the browser to be able to present you with information, layer 6 needs to be able to decode and format and encode with appropriate encoding scheme. And then the application layer is when the browser would be able to take that and give you the web page that you're visiting, if you're visiting the web page for using your network system. So the advantages of the OSI model would be dividing the network communication into sub-processes or subtasks, and it's used to develop, design, and troubleshoot the network. So in the case where if you have network connection, you would start with the physical layer. You got to check if your network interface card is connecting. And then in the next area, you would see if it's able to have addresses. And then you're going to be able to use the addresses, and you're going to follow it to the next layer and the following layer. So then I would see if it's connecting to the switch, which happens in layer 2. And then I would see how the switch is connected to the router and how that packet is being routed out. And so when we're looking at the browser, if the browser is not presenting any kind of web page, then we would need to follow the OSI layers and be able to troubleshoot and see if our system is physically connecting, if it's logically configured for connection, how it's connecting to the network appliances, and how the session is established or the data is being presented through the presentation and the application layer. So in our assignment, we are going to look at the next question. It asks you, in which OSI layer is responsible for code data translation and code formatting? That will be the presentation, which is layer 6. For question 10, which OSI layer provides interface with the programs? That will be application layer, layer 7. And for question 11, it asks you to identify the 7 layers of the OSI model. We would start with the first layer, that will be your physical layer. The second layer, that will be data link layer. The third layer is the network layer. The fourth layer is transport. Fifth is session. Sixth is presentation. And seventh layer is application. The way that I remember this is I use the first letter and I would make a little saying out of it. So it would be, people don't need to see purple alligator. And that's how I remember the all 7 layers of the OSI model. So for Network Plus certification, make sure that you know what each layer is accountable for. And then also all the 7 layers of the OSI model. So it also identifies some additional advantages for the OSI layer, which allows various type of network hardware and software to communicate, even though they were produced by different manufacturer. It also prevents changes in one layer that will be affecting another layer, so it will facilitate the development and the application programming for our system. Now, on page 7 of your notes, I also presented specific tasks that can happen in certain layer. So for application, this is when file, print, message, database, and application services happen. So in the case where the file can be opened or accessed or downloaded, or if you're printing a document, if you're sending messages, if you're accessing database, that will happen at the application layer. In the presentation layer, if we're using encryption, compression, or translation services, encoding, and so on, that will be happening in the presentation layer. Session layer is going to be responsible for dialog control. So when you're visiting a secure website and once it authenticates you, it establishes a session, and that happens here in this layer. It actually happens in the top 3 layers as browser is going to present you the website. Once you authenticate, it would also communicate with the server connection, and when it generates encryption, it's going to be at presentation, and all of that is on top of the session. Transport is going to be end-to-end connection, so TCP happens here where connection is established in order to have a session, in order for your data to be encrypted, and how that will be presented to you at the application. In network layer, that mainly is when we use IP addresses and routing, and that routing happens in layer 3, which is network. For data link, that will be data framing, and your switch is used here. This is why we would see switch table contains MAC addresses. For the physical layer, that will be the actual physical connectivity where cable and network interface cards are going to be at work. So below that, it would show you an example of how the user would be able to access data using a network system. Application provides the interface. Presentation presents the data and handle processing. Session keeps the different application data separate. And then the other layers are going to be established, the physical and the logical connection of your system. As it shows here with the transport. Transport makes sure that there's reliable delivery if you're using TCP, or unreliable delivery when you're using UDP. It also performs error correction before it retransmits. In the network, that will be logical addressing when the routers use to determine the path and route your data to the appropriate destination. Data link is going to combine packets into bytes and bytes into frame, in which MAC addresses is also used, and error detection, not correction. So data link is really for detecting data, and the correction happens in the transport. Physical is going to be moving the bits between the devices, and that's going to be to the voltage wire and pinout on the cable. So in the next part, we are going to look at a diagram that presents to you how the system is communicated over the internet. So the sender is going to connect to the internet service provider network, and the receiver is also connected to internet service provider network, which is represented as a cloud. And here what you see is, if we're using TCP, the sender is going to send a request, and that's called the SYN packet. And then the receiver is going to receive that. So once the receiver receives that packet, it's going to acknowledge that for synchronization. So the SYN is basically for synchronization request. The receiver is going to receive the acknowledgement of the request, and it's going to send the response back to the sender system. and it's going to say that I received your request. And so for the third round, the sender is going to acknowledge that it's ready to synchronize. And so with that, once it's synchronized, data can then be transferred. And this can happen within the network or beyond our network. So the data doesn't get transferred until there is acknowledgement that happens. Following that is going to be the connection oriented communication. This is just to ensure that your data is delivered to the appropriate target system. When establishing services, protocol is then need to perform handshake function as what you've seen in the prior diagram. And it takes place at the beginning of the communication session. Two computers would need to determine the rule of the communication, such as how fast it's going to transfer, what port it's going to use. And so it's also going to determine the proper way how the session is going to end or complete. So this is just to make sure that communication is established and it's going to be established in an orderly manner. So in the session, a reliable dialogue would be then started with the two computers, and because it's connection oriented, then we would have reliable communication between the systems. And the session will be maintained until the computers decided that it will end. So when we finish transferring the data, the session will end once those two systems would terminate the actual session. So there are the steps listed on what would be summarized from the previous section. Connection agreement after the request of synchronization. The segment acknowledgement will happen after that to establish the connection parameter or the rules. And then it's going to request a receiver sequence that would be synchronized. That's going to be both from the sender and the receiver, so it's bidirectional. And then the last segment is going to be the acknowledgement after it already respond to the request, acknowledge for the request. So it's going to acknowledge for synchronization. Then the agreement has been accepted, so the connection would then be established and data can be transferred. So for question number 12, it asks you, in the connection-oriented session, why do hosts establish connection parameters? It's a way for the host to establish rules of the connection or rules for the connection acceptance and data synchronization prior to the data transfer. So there gotta be an agreement between the two systems before the data is then being transferred. So in number 13, it asks you what is the purpose of flow control between the system. Flow control is just a way for the system to govern the amount of data that will be sent by the sender, because you don't want the data to be flooded, or you don't want the data to be minute where it would take a long time to send the data. It would prevent the host from one side of the connection to overflow the buffer. So we want to make sure that the data is going to have flow control, so that way it's not going to overwhelm the system that is receiving the data. So here we can state that flow control provides a means for the receiver to govern the amount of data that's sent by the sender, and it prevents the sending host on one side of the connection from overflowing the buffers on the receiving host. So flow control information, you can find that on page 10. And in flow control, here it incorporates that with the acknowledgement of the session. So the reliable data transport employ connection-oriented communication. So the segment delivered or acknowledged that would be sent from the recipient to the sender. And any segment that's not acknowledged, it would then need to be required to be retransmitted. And since we're using the TCP IP network, this is what's happening for the system to communicate. Segments would then be sequenced back into the proper order upon the arrival of their system. So in the data packet, you would see that there is a sequence number. And so that is how it's going to be able to track the order on how the data is arrived, and it's going to put things back together. A manageable data flow is maintained to avoid congestion, overloading, and data loss. So flow control is then being implemented so that way data is not overloaded or lost. So here's a diagram on how that would show flow control between the systems. In the connectionless communication, this is a form of communication in which system does not require to introduce itself or acknowledge or request synchronize. So it doesn't have to request for synchronization. And connectionless communication would happen with UDP, User Datagram Protocol, in which destination computer does not need to notify the source that the information is received. Whether it's received or not, it's not gonna matter. So in some protocol like UDP, it is connectionless and it doesn't care whether the recipient system is receiving the data or not. The type of communication, it would be unreliable, and there's no notification that would guarantee the delivery. It's definitely faster than the connection oriented. So when you compare UDP to CCP, UDP is faster in that it doesn't require the handshake or multiple acknowledgement between the systems. And so that will give you the main differences between the connection and connectionless. Now, for question 14, it asks you in which OSI model or layer does the switch operate? And that will happen in layer 2 is where the switch operates. So in the next section, it's going to go over the type of devices that are in the OSI model. So you might have Network Management System, also known as NMS. You also might have web and application servers, gateways, network hosts, and other devices like switch or security devices. So in an OSI model, we would see the network interface card happening at the physical layer, transceiver or hubs or switch happens in layer 2, and then routers uses layer 3, and for transport that will be beyond your router, so it would travel to the destination system, and then all of that will be presented, and the application would be able to access the data that was received. So at the physical layer, what you see is that data needs to be encapsulated. So the data has to go through encapsulation in which the protocol is wrapped for each of the layer, and each layer communicates only with the peer layer on the receiving data. So data encapsulation is also shown in the picture here. So at the physical layer, that will be sent to the cable and the network interface card is used. Then the physical layer would then send that to the second layer, which is then data link. And this is when MAC addresses is used. And then it's going to include the header, which is having IP header that's going to be carried into layer 3. And the data is also coming along after layer 2. So IP and TCP header is then going to be moved also into layer 3. And for the transport, it's only going to use TCP header. And then for the session, it's only going to deal with the data. Then in the next layer, the data is then converted for transmission and so on. So when you see this, when you send an email or use a chat message or send a chat message or use some kind of web application, all of this is happening on your device, between your device and the destination device. So in the second layer, this is when we would see frame. And frame is when the protocol data unit is used in a data link layer. And so in the result of that, after with the encapsulation, the data is transmitted over the physical layer. So frame is just a unit of transmission in a link layer that consists of link layer header followed by the packet. So what happened is it's going to package it into a transmission unit in which it would add the header so it would know where that data is going to go to and where that data is coming from. So each of the frame is then would be separated, and so there would be inter-frame gap. And how it's going to be able to track that, there will be a sequence value that would be presented so the system can track. So frame contain a series of bits that generally compose of synchronization bits, packet payload, and frame check sequence. So it also provides the example and a picture in your notes. So in a frame, you would see that there would be MAC address from the receiver and the sender. And then it also includes the packet, which is then being passed to the next layer. And the packet would include IP address of the sender and the receiver. And then everything is going to be encapsulated with the protocol and the data that would be part of the segment. And then after that, we would have the sequence value here for the frame. And sometimes it would be presented like this. So you would have the preamble for the certain bits. So that would be the front bits here. There are 8 bits that will be the preamble. 6 bits that are going to use for the destination address. 6 bits is going to use for the source address. 2 bits are going to be dedicated for the type. And then the data is going to be right here. And we're going to dedicate 4 bits for the frame check sequence. So as you can see, this is how your data is being sent when your system is using the network services to be able to transmit your data across. So in question 15, it asks you what type of devices operate in the physical layer of the OSI model. We can say network interface card, and that can also include cable, transceivers, repeaters, and hubs. For which OSI model does the router operate? That will be network layer. In the next question, it asks you, how does data is transmitted across the network? It would then be wrapped with the protocol information, which is known as an encapsulation process at each of the layer in the OSI model. So each layer, it does the encapsulation starting with the physical layer. For 18, it asks you describe what a data frame pertaining to OSI layer and the data transmission. So you can find this in the notes as well, but a frame is a protocol data unit at the data link layer at your DLL. And it also is a series of bits that consists of synchronization, packet payload, frame check sequence. It is the result of the final layer of the encapsulation before the data is transmitted. So a frame is a unit of transmission in the link layer protocol that consists of link layer header followed by a packet, and each frame is then would be separated. There would be an interframe gap, and it would use a sequence to be able to determine the frame order. And so if you return back to the notes, you can find the frame information on page 13 and 12. In the next section, we're going to talk about data packets. Data packets are used to transport user data from one network to another network. It would contain TCP segment and IP information. So TCP segment is carried in one or more IP packets, and in which it's carried into the Ethernet frames. So the protocol that would use for data traffic would be the routed protocols, and we would use internet protocol like IP or IP version 6 for routing. And route update packets are used to update all the adjacent routers about the network and all the routers within the network. So how it's going to see which routers are around it and with the, in the surrounding network, and so that way it can pass through those routers, or what routers are available inside the network that it's going to be receiving from, is that it would use a packet type called route update or route update. And in the router, you would see the protocol that often be used would be your routing information protocol, which we'll talk about later, RIP. And then there's RIP version 2. Also, Enhanced Interior Gateway Protocol, your EIGRP, or Open Shortest Path first. So it's going to look for the most available system first. So that will be OSPF. So the route update packets, it's really used to maintain the route table on each of the routers, so that way it would know the neighbor routers or the surrounding routers, so it can quickly pass your packets so it can reach the destination in a short amount of time. And here you would get a little picture that would show you how data is passed from one layer to another, and how on each of the layers certain headers are being incorporated. So for the TCP IP packet, you would have the version, the length, the type of service, and service is always correlated with protocol, total length of your data, identification flag and flag fragment offset, time to live. So when it exceeds the time to live, it either retransmit, or if it is connection oriented, or if it's connectionless oriented, then it would then just move on to the next packet. The protocol, the header checksum, source address, destination address, options, and data. So if you're pursuing CCNA and Network Plus, make sure you know the content of the packet and how data is passed between the layers. So here provides you with the image on page 14. It can also be presented this way, in which we talked about how the packet would be the content here. And inside the data segment, this is what you would see. So how does it know what type of data and how it would put the data back together is using this right here. So for your assignment number 19, it asks you what is a packet and how it is used in the network. Packets are used to transport the data through from one network to another network or through the internetwork. And a TCP segment is carried in one or more IP packets, which are carried in one or more Ethernet frames. So the frames contain packet information, which is then passed to the next layer, and that's how it's going to be using the packets in order to get the data to the transport layer. So you can think of it like a relay process, as each of the layer is going to have added information that you will need to be able to pass the data along and to be able to present that data to the application. In the next section, we're going to talk about the 802.3 standards, and this is used for Ethernet network. So this was created by Intel and Xerox. So 802.3 standard is what we see today in our home network and in our organizational network. The difference between 802.3 Ethernet and DIX Ethernet version 2 is the frame type. So that's just the two different type of network. One is going to be Ethernet network, or the other is going to be DIX. So DIX is different than the Ethernet in the frame structure. Now, when you look at the Ethernet standard, you're going to see that it also incorporates some of the coaxial cable type of network, so that would be known as the thin net and the thick net. So the 10-base-5 is used as a thick net, and it was the original Ethernet specification, so we're using copper here. And the maximum distance for this particular connection medium is going to be 500 meters, and the maximum speed is going to be 10 megabit per second. So whenever you look at this number again, like what we talked about in the last chapter, the 10 right here represents the 10 megabit per second. Same thing with the 10-base-2, which is the thin net. Also use coaxial cable, but just a thinner type of coaxial cable. Its distance is much shorter, 185 meters, approximately 608 feet. And the maximum speed again is 10 megabit per second. So you would see the value in the front of the base is going to represent the speed of that type of medium. The 10-base-T, and T here stands for twisted pair, that's your Ethernet cable. 10-base-T is going to also be 10 megabit per second, and because we're using twisted pair, that can be up to 100 meters, approximately 328 feet, with the speed of 10 to 100 megabit per second. So then we would see a 10-base-T, 100-base-T, and 1,000-base-T. And 1,000-base-T is where we're at now. So in our question number 20, it asks for Ethernet and how it's defined in which IEEE standard, and that will be 802.3. So after 802.3, we will revisit what's called the token ring, which is IEEE 802.5. This is an older technology that was used, and this standard passes a special frame known as a token around the network. So in a round-robin network where you would have the topology would be circular, in which the system, in order to pass the data, it would create a token, and that token would then be able to pass from one system to another in order to transmit the data. So the system that would receive the token, then it would then be able to receive the data or receive the transmitted data from the sender system. And it would be the data frame on the network with the address. So it would use the data frame with the system address. Now, to make sure that the workstation will not communicate simultaneously at once, there would be order and taking turn in the token ring aspect. Then we would then use the CSMA CD for collision detection. So in our assignment, we would then address number 20. Ethernet is defined in which IEEE? That will be 802.3. And in the following section, we will talk about wireless. So this concludes my video for part 2, which covers OSI model and 802.3. In the next section, in the next video, I will talk about 802.11, which is your wireless standards. So please watch the next video for the second part of the assignments. Thank you for watching this video.